good program has many measures. One of them is modularity. Let's assume a random algorithm, like finding an edge in a noisy digital signal. Among many solutions, you've developed a function like this one. And now you want to make an abstract component out of it to use several times. It's easy. Select functionality you want to include, then edit, create subVI. The very next step is double-click on the VI you've created. It opens the front panel. If you double-click with Control pressed, it opens the diagram. Let's start with front panel. Make sure the connector pane is this one. We call it 4224. When the VI is empty and you create it from scratch, those connections are empty. Those connections here are defined because we've created the VI from an existing code. You can empty it like this. Right-click, disconnect all. To make a connection, first click on the terminal you want to connect. Note that the tool changes to wiring. Then click on the control you want to at this terminal. Main data type of the function goes on top. When you're using files or ref nums, they go here as well. Error is always bottom left and right. Placing error cluster is a good manner as it allows to enforce data flow later on. So, main data input is top, error bottom. All additional parameters are here, inputs left, outputs right. You can set an input as required one. In that case, it must be connected. If you set an input as recommended or optional, add in brackets next to the label which value is a default one, and remember to make this value default with a context menu. Double-click on the icon. Layers. Delete the default one, then Templates. Use this one. Fill the top field with a color that's common for the group this function belongs to. Also define with letters, for example, math or digital. The main field should show the functionality in picture. You get some help with those glyphs here. You can also use a web browser or just try to be creative. When it's done, save. The decision about the icon drawing and a function name should be easy. If it's not, it may indicate that the function should be redefined. There are certain measures of a good subVI that you should keep in mind. Your program should be defined for single purpose like mean, Fourier transform, or sine. We name this property cohesion. The stronger, the better, and easier to name the function. The program should also be weakly coupled. That means it should be independent from other parts of your program. This part depends on both array and the parameter m. However, those two are related, and if one of them changes, like here, we remove last row of the array. This function doesn't operate properly because it's strongly coupled. Simple solution is to get independent from this m parameter and just calculate it here. Now, this function is weakly coupled and will work for any size of the array. We'll talk more about coupling and cohesion a bit later on various occasions. You should add the description of your program. Right-click on the icon. VI properties. Documentation. Write here what the function does and what are those additional parameters. Be clear about the functionality. You may add who made this function and when. Panels should be clean and elements should be placed to match connector pane. The best way would be to do like this. However, it is an unreasonable effort. This level of cleanliness is fine. In diagram, connect the error cluster and make necessary cleaning. A slightly better way of connecting an error is this. However, this is another effort that is often put off. This is how it looks when you make a subVI. Required terminal is bold. Recommended tells you which value is default. After you make a subVI, usually small cleaning is necessary to make the diagram look good and professional. Making good subVIs is important skill and tells a lot about the experience of a programmer. Naturally, there's more about subVIs, and we'll discuss it all eventually.